Giuseppe Duri, Director of Engineering, Massimiliano Bonanni, KDI Project Leader.
Good evening. Going back to what Francesca said about the new emission limits coming into effect on January 1st, 2013, the great challenge facing all engine manufacturers is to reduce the particulate emissions by one order of magnitude, which means bring them back to 1/10 of the existing value today. The easiest solution would have been to adopt a filter, a particulate filter, on all existing engines. We analyzed in depth and extensively this possibility, but we found out that it was not the best solution, the best user-friendly solution for the end user, for the OEMs, because a diesel particulate filter, or a DPF as it is normally referred to, brings along shortcomings, brings along inconveniences. First of all, a DPF during operation gets clogged, and it has to be cleaned. It has to be, as you said, regenerated. This regeneration means to burn the soot that is trapped within the filter. And burning the soot means to use other fuel. And this brings the fuel consumption to a higher value. So it has a negative impact on fuel economy. Then, during this operation of regeneration, there is an important heat release. So the generation of this heat has to be taken care of in the machine, either by shielding the hot parts or by ventilating the engine compartment. And this is no easy solution for a machine, especially for a smaller machine. Fourth problem, a DPF is a bulky object, the volume of which normally is 1.5 times the displacement of the engine. So the machine manufacturer has to take care of this big cylinder to place it somewhere in the machine. And this gives envelope problems, dimensional problems. And last but not least, still today, a diesel particulate filter is a costly object, is an expensive object. It is possible that in the future the cost will go down, but still today it's a high value and it will add to the cost of the machine so much. So, after all these considerations, we took a very challenging decision. And the decision was to design from white sheet of paper a brand new family of heavy-duty diesel engines that would meet the stringent emission regulation without the use of a diesel particulate filter. And I would like to hand over now to Mr. Massimiliano Bonanni, who will try to explain to us how we did achieve this. Thank you.
Thank you. Well, the only alternative to reduce particulate matter to 1/10 the present emission values was to concentrate our efforts in achieving clean combustion. The high-pressure 2,000 bar common rail system of the latest generation, capable of multiple injection events managed by the engine control unit, combined with an electronically driven EGR valve, which recirculates the right amount of cooled exhaust gas, enables emission levels to meet the new requirements while providing premium performance and without the use of after-treatment systems. But let's see some details of the common rail solution here. We chose the most advanced common rail system on the market, 2,000 bar. This high pressure creates a very fine and highly penetrating spray that ensures clean combustion. And to maximize the air and fuel mixture, we selected a 4-valve per cylinder layout so that the injectors can be installed in a central and vertical position and to maximize the engine air intake flow. The adoption of a west-gated turbocharger, along with the 2000 bar and the 4 valve per cylinder layout, greatly reduced the particulate matter output, hence the possibility of avoiding the DPF. But particulate matter reduction was not the only problem to be overcome. The consequential NOx formation due to the clean combustion, which means high temperatures and high pressure, is controlled through the recirculation of cold exhaust gas managed by the engine control unit. The EGR valve is located upstream the main EGR cooler in order to avoid valve sticking and so reliability, robustness, as Francesco said. And the exhaust gas is cooled through a two-stage cooling system, a gas flow inside the cylinder head and the main EGR cooler. But this is the Tier 4 final solution, the one ready for the next regulation, which will come into effect in 2013. But as a global engine manufacturer, we want to be able to meet the requirements of countries subject to less stringent emission norms. Therefore, the same base engine architecture was also developed for a purely mechanical injected system, which means that the high-pressure common rail pump and the mechanical rotary pump can be installed on the same engine block, the same cylinder head, the same distribution gear train, the same engine. Thus, avoiding the drawbacks of the DPF, we can provide a complete range of engines, Tier 4 final or mechanical version, all offering the same base sophisticated solution: high mechanical efficiency, a structural block specifically designed for low emission noise and vibrations, and state-of-the-art honing process for reduced oil consumption. I would say a unique product and a unique proposition for customers, and let me say, the next engine generation.